In this second video, we're going to take two more examples that are slightly more complicated and show you how those work. So let's first of all look at what the given and find are. Our given is in particles up here, and we're looking at particles of aluminum hydroxide, and that's why I've already done the little G in the box for the aluminum hydroxide. G for given. Now, our next one was the find water, and the find for aluminum is already marked down here. So we're ready to go. Let's look at what's happening in the chart though. Aluminum hydroxide is given to us as particles, so we're up here, and here's the path we got to follow. We got to go to get to moles, and then we're going to have to come in the next step to follow this line to get to moles. Now we're in moles of the new stuff, the water, and we're done. Okay, so this is the find right here, and this up here is the given points. So you can see given always on the top row, find always on the bottom row. And now we're going to go ahead and run some numbers. So let's look at our given. Our given is going to be 2 times 10 to the 23rd particles over 1. And what are the particles of aluminum hydroxide? Okay, next. What is going to be next, folks? What has to be on the bottom of this fraction? Particles. Right. Let's just do particles. Of the AlOH3. And what do we have on the top? That's how many 6.02 times 10 to the 23rd is the particles of aluminum hydroxide in what? 1 mole. Right. 1 mole of aluminum hydroxide particle. Oh, no, that's just moles. Okay? All right. Now, what we've just done is we've gone from particles to moles. And we're ready for our next step. And what's that going to be? The mole ratio, right? Okay, so on the bottom of the next fraction, what are we going to have first? Right, moles of aluminum hydroxide. And what's on the top? The find, which is moles of water. Moles of H2O. All right, now let's look at the numbers that go in front of them. What's the number in front of aluminum hydroxide are given? 1. And the moles in front, or the number in front of the water? That's 3. Okay, so there's our 3 to 1 ratio. And what's our last step going to be, or are we there? We're done. Yeah, there is no next step. Oh boy, just about made that mistake again, huh? Okay, so when we run the calculator on this, what we want to do is punch in our 2. Forget about the 10 to the 23rd. So we're going to put in 2. The 6.02 times 10 to the 23rd is on the bottom. So now we're going to hit the divide key and put in the 6.02. And you'll notice that the 10 to the 23rd particles will cancel out. Isn't that nice? Yeah. Makes the numbers easy. Yeah. Okay. And now what's our next number? 3. So we're going to put times. That's on the top. That's the 3 moles of water over 1 mole aluminum hydroxide at the end of the calculation. And so we put our 3 in and hit the equal sign. And I get 0.9966. So this is actually going to come out to when we round to just one sig fig, so this is going to be 1. All right, and what is that? That's this guy canceled out, this 10 to the 23rd canceled out, and the moles of aluminum hydroxide canceled out, so we have 1 mole H2O, and we're done. What? Oh, yeah, got to get the canceled particles here. Particles of aluminum hydroxide are canceled too. Very good. Is this starting to make some sense here? We ended up right here. That was our find, and we've got our number at the end. Question?
What about particles to particles? What's the...
Particles to particles would be the same kind of deal. The only difference is there would be one more fraction right after this guy, and that would be the particle and the envelope, right? Yeah, that'd just be the one additional fraction. And so to get moles into particles, we'd have moles on the bottom of the next fraction if we continued this calculation, and then the particles would be on top. Okay. Okay, so that's one of the more complicated ones. Now we're going to do a 4-stepper and see how those work. And we'll just pause for a moment. While I paused the video, I was able to do the erasing and shorten it down a little bit. So here's our new problem set up, and this time we're going with 5 grams of aluminum chloride as the given, which is of course up here, and then we're going to be looking for how many grams of hydrochloric acid we can get from that. So let's go ahead and figure out where we're going to go, and let's also circle our given and find. Aluminum chloride is here with no coefficient, and the hydrochloric acid is over here with a coefficient of 3. And so our mole ratio is going to be 3 to 1 hydrochloric acid to aluminum chloride. And now we need to go up and see where we are starting on the chart. Right up there, yeah? Okay, and that's the moles or grams of aluminum chloride. And then we're going to be going over to here. And then, of course, once we're to moles, we can come on down. And once we get to moles here, where are we going to go? Grams, right, going to grams. And what kind of grams will we have here? HCl? Yeah, okay. So let's go ahead and run the problem. And now you can see we're going to have a total of 4 fractions. Think of it like you're driving your car. You get in the car, you put the key in the ignition, and start the motor. You have just created your first fraction, which is going to be right here. Okay, that's your first fraction. Now you're going to go to moles. That's your first trip in the car. Okay, follow the blue line. That's the map quest that is taking you from where you are, current location, to where you're going, the destination or the find. And so our first trip is going to be to go to moles, and that will be our second fraction. The next trip is to go to moles of the new stuff. That's our third fraction. Have you guessed how many fractions we're going to have? 4. Right. Okay, our last trip, going to grams. All right, let's figure it out. We got 5 grams of aluminum chloride over 1 times. Now, what are we going to have to do first to get to moles? We're looking for this guy. How are we going to find him? Huh? Molar mass. Okay, when you run the numbers on molar mass for aluminum chloride, oh, I haven't done that yet. Okay, we got aluminum chloride going to be down at the bottom because we have aluminum chloride up here. So this is going to be grams of aluminum chloride. On the top, what are we going to have? 1 mole of aluminum chloride, because that's how many grams are in 1 mole of the aluminum chloride. And so the grams that I come up with is 133.5. 10 looks like 5. Okay. Now, that got us to here. Now, our next trip, what are we going to use to get from moles of one to moles of the other? Balanced equation. Our boxes are circled. So, who has to be on the bottom when we do this? Mole of aluminum. On the aluminum chloride. And so with the number in front of aluminum chloride is 1, and then we're going to have moles of what? HCl. Yeah. Okay, and that'll be 3. And so now we've got our mole ratio. We've made it to here. One last trip, and that's going to be what on the bottom? Moles. Moles of HCl. And what are we looking for? Grams. So HCl is chlorine for 35.5 and hydrogen for 1. So that gives us 36 grams. 36.5 grams of hydrochloric acid. And that's what we have, the number of grams for 1 mole. And now let's go ahead and run the calculation. And when we do that, and when you run that calculation, you come up with 4.1. This is going to be grams of HCl. Let's cancel everything out and make sure that that worked out correctly. We've got aluminum chloride canceling out here, grams for grams. Moles of aluminum chloride canceling out here, moles per mole, and 3 moles of HCl or moles of HCl with moles of HCl. And our only unit of measure left is grams of HCl. So we know we've got it right. And that's how you're going to use this chart to the best effect and get the right answer every time. Thank you for listening.